My name is Andreas Wirth. I'm working at the Austrian Meteorological Institute in Vienna. The primary intention of this weather briefing was that my colleague Liliane Hofer will lead this session. Unfortunately, she is on sick leave, so I will have to do both presentations we have foreseen for today. And these both parts are listed here. First, the present weather, and a short overview on the actual synoptic situation. And this is the part Liliane should have done, and I will try to replace her, though I'm not so sure that I can do it with the same experience she has. And in the second part, I prepared a retrospective to the heat of the summer 2015, and I prepared some very nice slides. So let's start with the present weather situation. Here you see the infrared image of today morning, 6 UTC, and you see that the weather is dominated by two pressure systems, a high pressure here over Scandinavia and the Baltic Sea, and a low pressure very dominating the northwestern part of Europe. And we have also a very small low in the central part of Europe, based over the Balkan, over Croatia. So as you can see here, this very strong high, which is blocking all the fronts coming from the west. It has a name. It's called Isabel. The German Weather Service gave this name, or let's better say the Freie Universität Berlin is giving this name, and the German Weather Service is using this name. So this high pressure area is called Isabel, while this small low here is called Florian. And this year, all the high pressure levels have female names and male names for the lows, and it changes every year. So, and if you are interested that your name is for one of these high or low pressure areas, you can buy this name. And I had a short look in the internet today. The price is yes, quite high. It's 355 euros for such a name, and 81 cents. And I don't know how this 81 cents comes from, but that's the price for such a very nice high pressure area. By the way, Isabel has also another name. It's called Schlocklof. So it's probably somewhere from the region of Berlin. But we are happy that we call it only Isabel. So, next slide shows you the surface pressure in addition to that. And you see that the surface pressure shows a low just beneath the upper level low over the Atlantic here. That means the vertical axis is quite vertical. No more strong development to expect. And here over Croatia, the surface low is not very expressed. So I think we can talk of this region and name it upper level low. So what do we see? Where are the fronts? We see some kind of cold front here, which is which comes from the north and goes down to the south, but it's blocked by this high pressure area here. So it does not move more to the east. There is some secondary cold front here arriving, as I can see in the satellite. Then we have a kind of occlusion here. Maybe a warm front and then a cold front in the north. Here over Central Europe, we can also distinguish kind of occlusion, maybe also a kind of warm front and a cold front. But this cold front here is marked by cellular cloudiness here. And this is probably, it was 6 o'clock in the morning, this is probably, or for sure, some active thunderstorms. And I verified it with the flash detection, and here you can see that we had some active thunderstorms. These are the lightnings in the past hour. That means from 5 UTC to 6 UTC in the morning. That means here in this region we have some active thunderstorms embedded in this maybe upper level front in connection with this low pressure area here, upper low pressure. So now we defined the fronts. What does the next slide show? It's the dust RGB. We see here the vast area, the vast cloudless area of the high pressure area. There are no clouds. We have also here the Azores high, and the Azores high with the high pressure is reaching into Western Europe and dissolving the clouds. Only over the North Atlantics we find some clouds, and they are depicted in red and in green colors. And these red colors means that we have opaque, very high cloudiness with lots of ice crystals in it, while green represent mid-level cloudiness. So we have here in the occlusion, we have some very high reaching cloudiness, some parts here in this wave area, there's a frontal wave, some high ice clouds, opaque ice clouds, and here also in the upper level warm front, which we detected here near the upper level low. And here in black we have some cirrus clouds. Yes, this is also very nice to see. So let's continue. This is the equivalent potential temperature, 850 hectopascal, and I put it here because we see here some very nice boundary over the Atlantic. That's something we did not really distinguish in the satellite image because they are only low clouds, but in fact we can see here a very high gradient in this numerical field. This is quite interesting. So there seems to be some air mass boundary in this region, cold air from the north coming to the southeast and building here this boundary. And the next slide shows you the temperature here in 500 hectopascal, and we see that there is a gradient, especially here in the temperature field. But here, where we saw the strong gradient in the equivalent potential temperature, the temperature gradient is not that high, at least in 500 hectopascal. And I also looked on the ground, in 2 meter, there isn't a temperature gradient. So these are surely two different air masses. I marked them here, polar air mass, and here some warmer air mass, but they are primarily characterized by humidity differences and not so much by temperature differences. So that's something we saw primarily in the numerical fields, not so much in the satellite images. Let's have a short look on the nowcasting soft products. Here you see the precipitating clouds. This is a probability product. If the probability for rain is higher than 35%, then it's yellow or red. This is not the case here in this analysis at 6 UTC. We have minor probabilities for rain, though it was raining this morning in Vienna when I got up in the morning at 6 o'clock. It was still a little bit raining, so there is some signal here. Maybe you can verify it for other regions. The probability of rain is not very high from this product. So there's another precipitation product from the nowcasting stuff, and this is the convective rainfall rate. And here we see that the high clouds over Hungary, yes, it's Hungary, I put a star, and Romania are analyzed as convective clouds with some rain intensity. The rain intensity here is given in millimeter per hour. And here where we saw the flashes, there is not so strong rain in this analysis. Most of it is analyzed here, and Iceland in this occlusion part here of the cold front. So the last slide now related to the present weather situation is the forecast. I took the American model, the GFS, and we see here the forecast for the next 6 days. So what will happen? And something quite interesting is going on. You see the low pressure area, which is weakening until the weekend, and then reaching a minimum here on Sunday, and on Monday getting stronger again, recovering until the middle of next week. So it has a weakening on the weekend, but then gets stronger again. On the other side, our Isabel high pressure area is weakening all the time until it's really disappearing by Tuesday next week, almost disappearing and getting weaker and weaker. So what will happen? This recovering low pressure area will bring us more warm and humid air from the south and bringing summer back again, because since last weekend summer has disappeared, is recreating to reappear next week. So we have this week now at least for Central Europe, quite nice temperatures around 20 degrees. So much for the actual weather situation. And now I would like to continue and give a retrospective glance at the summer 2015. This is a chart which is plotted on the ZAMK website, and it shows you the mean temperatures of the day for the whole year 2015 until now end of August. And you see this black line here. This is the mean daily temperature of these 30 years from 1981 to 2010. You see it here. So this is a climatological mean daily temperature, if you want. And this part here, this temperature chart here, shows the temperature, the mean daily temperature of the year 2015. So you see that all in all the year has been much too warm. The cold phases are very short. We have much too warm temperatures, and this is not only valid for 2015, this has been the case for the previous years. What you see here below is the summed precipitation over the year, and you see that from May on we are lacking precipitation at the station. This is valid for representative for Eastern Austria, so for Central Europe. We are lacking of precipitation, and we had some precipitation in the last days, but not very much. So all summer was much too dry. So I zoom in now to the summer months, end of June, July, and August, and what you can see here are 3 periods with very warm temperatures. Let's call it heat waves. 3 heat waves in Central Europe. In other regions of Europe, it might be different. For Spain, for example, it might look a little bit different. But for Central Europe, we had 3 very distinct and very intensive heat periods. This is clearly visible here in this temperature chart. So we commonly make the use of the term heat wave. But what is a heat wave? How can we define that? So if we want to define the term heat wave, we have to take into account a deviation, of course, hopefully a strong deviation, of the temperature from the climatologic mean. This is the characteristic of a heat wave. It must be warmer than usual. It should have a certain duration. The longer, the better for the heat wave, of the temperature anomaly. And we have to see which geographical region is affected by this phenomenon. So these 3 points must be contained in the definition of the term heat wave. And in our Met service, we use a definition provided by Jan Kieserli. I don't know if the pronunciation is correct, but he's a Czech meteorologist, and he made up a definition of the term heat wave containing all these three factors. And on my next slide, you will see this definition, and he defines a heat wave, or a heat wave takes place when at least on 3 consecutive days the maximum temperature exceeds 30 degrees. Yes, and if we have these 3 days with maximum temperatures above 30 degrees, it continues as long as the average of this period is above 30 degrees. But there is a restriction. There shouldn't be a day in between this heat period with a temperature maximum below 25 degrees. So as soon as we have a day below, with a maximum temperature below 25 degrees, this heat wave is finished. So this is a simple way to define a heat wave. So as I told before, we had 3 heat waves this summer. Let's start with the first one. End of June and beginning of July 2015. We had a high pressure area, a high pressure system called Anneli, which formed end of June and moved over the Baltic Sea. And at the beginning of this phase, we had very high temperatures over Spain. And temperatures, we had already a heat wave in May in Spain, if you remember. But in the summer months, this was the very first heat wave in Spain, and beginning in Spain with temperatures up to 43 degrees. The same for Algeria and Morocco. Portugal was not so much affected. We will see it in a chart later on. So, a few days later, the heat propagated eastward towards France, central France and England. And here some temperatures. London Heathrow on 1st of July, 36.7. This might not be hot for Spain, but hot for England. And this is an all-time July maximum on this 1st of July. In Maastricht, 1 day later, the temperatures reached 38.2 degrees, and this was the hottest July day ever in Maastricht, and the 3rd hottest day ever in the Netherlands. So this was the 2nd July this year, during the first heat wave. So the heat propagated and reached also Central Europe. We have here a station in Germany. It's called Kitzingen, and it measured 40.3 degrees Celsius on 5 July 2015. And this is the highest temperature recorded in Germany since 1881. Then the heat wave propagated to more southern parts early July. It reached Austria, Hungary, and the Czech Republic, but without breaking any records. So here is a nice chart where you can see the daily extreme temperature maximum for this first period, for the beginning of the first period from 28 June to 4th July. And what you see here is quite easily to understand. You have very high temperatures in the south of Spain, in France, and in northern Germany. And in Spain, we usually expect high temperatures in summer. In southern France also. So maybe the next chart is more easy to interpret and tells us a bit more, because it shows here the deviation from what is normal. And you see here that Spain has been deviating on the plus side, but France and the Benelux states, also Germany, is much more affected by this heat wave because the deviations from normal is much stronger. So in this first period, you see that Spain, France, and Germany is affected. Portugal, as I have already said, is not so much affected, and also Greece, Macedonia, Bulgaria are, in contrary, rather a bit too cold in the beginning of July. So this first phase continued then, but ended in the northern part of Europe with the arrival of some cold fronts. But it continued in the southern parts of Europe. So Italy, the Balkans, Switzerland, Hungary were strongly affected in July, while the northern parts of Europe were suffering only for a very short period under this heat. So for Geneva, we have some other temperature records which were broken then on 7 July, 39.7 degrees, and this is the highest temperature ever measured north of the Alps. So Vienna had some very hot nights in this period, on 7 or 8, I cannot remember anymore, with 26.9 degrees temperature minimum during the night. Lucky for me, I was not in Vienna during that time. I was on holiday, so I did not experience it myself. Seibersdorf, which is a small town located southwest of Vienna, recorded 30.4 degrees at 8 o'clock in the morning already. So cold fronts then crossing the Alps ended also this first heat wave of the summer for Central Europe. So you see that towards mid of July, the heat wave is continuing in Spain and in Central Europe, and also affecting now Italy, and the temperatures start to increase also over the Balkans. The second phase then starts mid-July, except for Spain, as I mentioned before, because in Spain the first heat wave and second heat wave were not separated. But for Central Europe, the heat wave was shortly interrupted and started again mid-July. You see that the Azores high is very pronounced here. This is a chart from KNMI from the 14th July. The high pressure area of the Azores reaches far into Europe. All the frontal systems here are blocked and are moving along this line here over the North Atlantic and the British Channel towards Denmark and Poland. During the second heat wave, the temperatures rose over 40 degrees in Italy. We had some temperatures, very high temperatures in Croatia, Split, 40 degrees, Montenegro, and also parts of Romania with temperatures up to 39 degrees. So very high temperatures. And what you see here now, characteristic for the second heat wave, not the eastern part of Europe was affected, but not the western part of Europe was affected, but the eastern part this time was strongly affected, starting from southern Germany, Austria, far into the Romania and Ukraine, and going also down to Bulgaria, Macedonia. So in the second phase, which is here depicted for July the 19th to the 25th, you see the temperature anomaly over Eastern Europe. So the end of July, the warm air masses withdraw, and this was the end of the second heat wave. Also again, due to the arrival of cold fronts, you see here the temperature anomaly for 26th July to 1st August. You see now colder temperatures over Central and Northern Europe. Still, it continues to be hot in southern Spain and in the southern Balkans and in Greece and Turkey. But at least for most parts of Europe, there was a short relief. This cold fronts also brought some very intense thunderstorms and heavy rain. And here's an image from, I can remember very well because it was in the news. Rauris is a inner alpine valley near Salzburg, and there were some very heavy landslides, strong landslides, which were crossing or cutting the roads, and parts of the valley were not accessible for 2 days. So the third and last phase started with the building of the high pressure system Finnchen, and this installed over Central Europe end of July. And a very intense low pressure system started to build up over the British Isles and led subtropical air from the south towards Central Europe here. And we have here two charts, beginning of August and middle of August, and you see that the longer the heat period lasts, the stronger the temperature anomalies are. And this time, Central and Eastern Europe again were affected by the third heat wave. This is one of the characteristic charts of this day. Weather charts. This is again from KNMI. We have the system over the North Atlantic, and we have the blocking high here. We have a baroclinic boundary which lasted here for many, many days, and temperatures were twofold. We had very nice low temperatures in the western part of Europe and very hot temperatures in the central and eastern part of Europe. So Hungary, Poland, and Austria issued heat warnings, and sometimes for some regions for up to 10 consecutive days. So it was really hot and very difficult to work during this period. So what were the impacts of these heat waves in the summer 2015? So these very high temperatures, anomaly high temperatures, caused serious damages in agriculture, you can imagine, but also for fishery, the Mediterranean Sea, but also the lakes in Europe were affected, and due to the high temperatures, the amount of oxygen is reduced, and this led to fish kill. We had very low water levels in rivers, so the production of electricity was affected, at least in Austria. High risk for wildfires for a long period in Central Europe. Highways, roads, railways were damaged by the heat, and we had also hails and thunderstorms which caused severe damages. This is one image. This was taken during my holiday period in a town next to where I passed my holidays, and in a few minutes there were so much hail, you can see it here on the ground, which destroyed many cars and many windows of shops and houses. It was really terrifying to see that. So this was a short retrospective to the summer 2015, and I closed this weather briefing with a nice image of the Rhine with very low water. I don't know if you have ever seen that before, and you can imagine how less the rain was in this period. So I thank you very much for listening.